We're getting into factoring a little bit here. So today we're just going to try factoring using the GCF, the greatest common factor. So factors are numbers you multiply to get together to get another number. So if you were thinking factors of 12, we're saying what pair of numbers can you multiply that gives you 12? 6 and 2, 3 and 4, 1 and 12. Those are all factors of 12. Oh, here we go. List the factors of 12. Now, I'm going to recommend that we list them as pairs like that. So like 1 times 12, 2 times 6, and 3 times 4. You don't need to say 4 times 3 or 6 times 2. We've got the pair there. The order doesn't really matter. Factors of 30, well, let's start with 1. 1 times 30, 2 times 15, I know 3 times 10, 4 doesn't go in there, 5 times 6. That's all of them. Common factors are the factors they share. So, common factors of 12 and 30, which numbers show up in both of them? Well, I see they both have a 1, they both have a 2, they both have 3, and 6. Those are all their common factors. 1, 2, 3, 6. The greatest common factor is the largest of those common factors. So obviously the largest one is 6. So 6 is the greatest common factor. It's the greatest number that can get multiplied into both of those. Finding the greatest common factor. So 6x squared and 5x squared. First, when I see something like that, I look at the numbers, 6 and 5. The greatest thing that goes into 6 and 5, or that they have in common, is 1. Do they both have x's? Yeah, they do. They both have x squared. So our greatest common factor would be 1x squared. Now clean that up a little bit. 1x squared is just x squared. You hop over to number 2, and I'm looking at 15 and 20, and I'm trying to think, what number can go into both of those? 1, sure, but also 5. So 5 handles those. Do they both have y? Yeah, they do. This one has y to the third, and this one has y to the first. You have to have something that they both have. So you couldn't say 5y to the third, because this one doesn't have y to the third. So when you're dealing with exponents and variables, you go with the smallest exponent. So we'll say 5y to the first, 5y. Here, 4x squared and 5y to the third. 4 and 5, largest thing they have in common is 1. Do they both have x's? No. Do they both have y's? No. So the greatest common factor between those two terms is just 1. 8a squared and 28. The biggest number I can think of that goes into 8 and 28 is 4. Do they both have a's? No. So just 4. What? Now that is the first step when we're going to start factoring things. You always look for a greatest common factor. So if you look at this example, 15x to the third minus 6x squared plus 21x. First thing you do is you find the largest thing that goes into all of those. I see that 3 goes into all of those, and I also notice that they all have an x in common. So 3x would be the greatest common factor. Now what we're going to do is, theoretically what we're doing here is we're dividing each of these terms by 3x. So we're doing 15x to the third divided by 3x minus 6x squared divided by 3x plus 21x divided by 3x. I don't like thinking of it that way. I kind of like thinking of it like a puzzle. I'm saying 3x times something gives me 15x to the third. Now I know 3 times 5 is 15. Handled. Remember when we multiply bases like x times x to the fifth, we add the exponents. So we need the exponents to add up to 3. Currently I have x to the first, so that means I need 2 more x's. So 3x times 5x squared gives us 15x to the third. Now I have to say 3x times something gives me negative 6x squared. Well, 3 times negative 2 is negative 6. I have x. I need x squared, so I need 1 more x. And then 3 times something gives me 21. 3 times 7. And we've already got the x, so we don't need any more x's. So this would be our final answer. Find the common factor first, and then figure out the rest with a little puzzle. So look at 5. 4x to the second plus 6x. I see they're both even, so I know 2 goes into both of them. They also both have at least x to the first power. I'm thinking in my head, 2x times something gives me 4x squared. Well, 2 times 2 is 4. X times x would give me the x squared. Now I have to think 2x times something gives me 6x. 2 times 3 is 6, and I already have the x. 2x times 3 is 6x. Done. Let me get this out of here. 3x minus 6. 3 goes into both of those. 3 times what gives you 3x? 1x, right? 3 times x is 3x. And 3 times negative 2 gives you negative 6. Whew. All right. You look at number 7. 10, 2, and 5. The greatest common factor is 1, and they all don't have an n. So you don't factor out a 1. So what we would say for this one is not factorable. And that's okay. Number 8, 9h to the 8th, 18h to the 3rd, 6h to the 2nd. I see the numbers in front. I know 3 goes into all of them. They all have at least h to the 2nd power. Look, let's get the numbers in front first. 3 times what gives you 9? It's 3 times 3. 3 times what gives you 18? That's 3 times 6. 3 times what gives you negative 6? Negative 2. And then we can handle the h's. Look, we already have 2 accounted for out here. So for the first one, we need 8 total. We have 2. That means we need 6 more. 3h squared times 3h to the 6th gives you 9h to the 8th. Here, I have h to the 2nd. I need h to the 3rd. That just means we need 1 more h. That's it. And the last one, we have h to the 2nd. We need h to the 2nd. We've already got them all. We're good. Here it is. All right. These are the last 2. So I think you should try it. Try the rest of the notes. I'm going to quickly go over them here. So pause the video and then check in with your answers. There it is for our GCF's greatest common factor. Now we got to factor them.